Good day everyone, you are welcome to Catch Your Math class. In this tutorial, we provide solution to these past questions. So this is Cambridge Mathematics, P5, and it is probability and statistics. Okay, so the total questions here, we have 6 questions and we have to answer all. Okay, so let's start solving the problems. Okay, from the first questions here, a bag contains 9 blue marbles and 3 red marbles. One marble is chosen at random from the bag. If this marble is blue, it is replaced back into the bag. If this marble is red, it is not returned back to the bag. So meaning that when you select blue, blue is with replacement, while red is without replacement. So whenever you select blue, you have to return it back to the bag. But when you select red, so you don't need to return it back to the bag. Okay, so now we have to find the probability that both the marbles chosen are red. So let's write out the given parameters here. Okay, let's say number of blue marbles that we have here, we have that to be 9. Okay, and number of red, we have 3 red, and total marbles, we have that to be 12. And of course, we know probability to be number of outcomes over total number of possible outcomes. Okay, so for us to get for both to be red now, that means we are looking for the first one to be red and the second one is also red. So which happens to be probability of R1 times probability of R2. That is the meaning. Okay, so to select red, now when you select red now in the first selection, and that will be 3 over 9 because the number of red marbles we have here is 3 and the total is 12, so it will be 3 over 12 rather. So the first selection is 3 over 12. Now don't forget here, selecting a red is with replacement, is without replacement. Okay, so this will affect the probability of the second selection now. So you've selected one already out of the 3, so that means the number of red we left with now will be 2, and it will affect the total marbles as well, and that will be 11. So meaning that the probability of getting red in the second selection now will be 2 over 11. Okay, so we can make use of calculator to simplify this, and this will give us in the simplest form, this will actually give us 1 over 22. 1 over 22. So that is for the first question. That's for 1A. Okay, for 1B, find the probability that the first marble chosen is blue given that the second marble chosen is red. So this is just like a conditional probability. Okay, and this can be denoted as probability that the first marble chosen is blue, okay, given that the second marble chosen is red. So the first one is blue, so B1, given that the second one is red, which is R2. This is what we are looking for, and we knew the formula of this to be probability of B1 intersection R2 then over probability of R2. Okay, so that is the formula for that question. So which is that probability of getting B1 the first selection given that the second marble chosen is red. Okay, so all we just need to do is to find the probability of B1 intersection R2. Okay, so B1 implies that getting blue in the first selection now. So we knew the number of blue in the marbles to be 9 and the total number of marbles is 12, so that will be 9 over 12 times, and of course blue is with replacement. Okay, so when you select blue, then you have to replace it back. Now to get red in the second selection now, so it has not reduced, so that will be 3 over 12. Okay, where 3 is the number of red that we have there. Now the next thing to find here is probability of R2. Okay, so that means the second selection is red, so that is what you are looking for. Now for the second selection to be red, so there are two possibilities here. Okay, is that the first one is red and the second is also red, or the first one is blue and the second is red. So we have to consider the two possibilities, meaning that we look for probability of R1 intersection R2 plus or probability of B1 intersection R2. So the first one here is red, and the second one is red, and the second one is red as well. Why here the first one is blue, why the second one is red? Okay, so and to get the probability of that, so when the first one is red, that will be 3/12 multiplied by, and of course you knew that whenever you select red, you have to, it is a selection without replacements. Okay, for you to select another red now, so you will left two red, okay, and that will affect the total as well, so that will be 2/11. So that's for the first case. Then second case, we have B1 selecting blue in the first one, that will be 9/12 times blue is with replacement, so this will now be 3/12. Okay, so we've gotten the what's it called, we've gotten value for B and B1 intersection R2 and the probability for R2. So all we need to do now is to substitute that here, okay, to get the final answer. Okay, so which is probability of the condition that we have here, the formula, that's B1 R2. So here we have 9/12 times 3/12. Okay, then over here we have 3/12 times 2/11 plus 9/12 times 3/12. Okay, so when you simplify this, you eventually have the 3/41, and this is 0.805 in 3 significant figure. So that is for 1B. Okay, now we can move to number 2 now. Okay, so number 2, Sam is a member of a soccer club. She is practicing scoring goals. The probability that Sam will score a goal on any attempt is 0.7, independently of all other attempts. So that means it is independent probability. It is independent probability, meaning that the occurrence of one will not affect the occurrence of the other. So that's the meaning. And for that reason now, remember you are given that Sam will score a goal on any attempt to be 0.7. That's the probability. So probability of scoring now, we denote that to be x. We have 0.7, and y probability of x prime will be 0.3. Okay, because probability of success plus failure is equals to 1. Okay, so that is not new to us. Probability of success plus failure is equals to 1. So x prime will just be 1 minus 0.7, which will actually give us 0.3. Okay, now Sam makes 10 attempts at scoring goals. Then find the probability that Sam will score goals on fewer than 8 of these attempts. So the first thing here is to understand where this question is coming from, which of the distributions this question is coming from, and of course this is a binomial distribution. So you are looking for number of successes in n trials. So that's what you are looking for. So where n here, okay, we are fn here to be 10. Okay, n is 10, and r here, so the success now we are looking for that, and r is fewer than 8. That means r is less than 8, so which implies that we are looking for probability of r less than 8, which is equivalent to probability of r less or equals to 7. Okay, and this as well can be written as 1 minus probability of r greater than or equals to 8. So that is the meaning. Okay, and if you are to make use of the second one here, all we just have to do, that is probability of r less than 8 is equals to 1 minus probability of r equals to 8 plus probability So we have probability of R is equals to 8, okay, plus probability of R equals 9, then plus probability of R is equals to 10. Okay, so this is where we have to stop because NA is 10. Okay, so we look for each of this. So let's start with probability of R is equals to 8. So when R is to 8, don't forget the formula for combination is for binomial distribution is n combination R, p raised to power of R and q raised to power of n minus R. So where p is success and q is failure, of course. So when you substitute that here, now let me just substitute everything here in this equation. This side, let me put that here. So I will just substitute the value of p, q, and r in this equation because we don't have enough space. So, but don't forget our p here is 0.7 and q is 0.3. So let's do that now. So for r less than 8, so that's 1 minus n is 10. That will be 10 combination 8, 0.7 raised to power of 8 times 0.3 raised to power of 2. Then plus 10 combination 9, 10 combination 9, okay, so times 0.7 raised to power of 9. I don't have enough space, I just have to manage the space. 9 then multiplied by 0.3 raised to power of 1, okay, and the last one is 10 combination 10, 0.7 raised to power of 10 times 0.3 raised to power of 0. So you close that. So of course we can use calculator to get the final answer here, and when you use that you will actually obtain 0.617 as the final answer to that. Okay, then to B, find the probability that Sam's first successful attempt will be before a fifth attempt. Find the probability that Sam's first successful attempt will be before a fifth attempt. So that means we are looking for first success before fifth attempt. So before fifth attempt means that the first success between the so that means the first success is between the first attempt and the fourth attempt. Okay, and for that is not a binomial distribution again. Okay, because for binomial distribution we are looking for number of success in n trials, but of course this one we are looking for first success, okay, in n trials. Okay, so that is the meaning of that, and for that reason now this must be geometric distribution. Okay, so that must be geometric distribution, and for us to get that now, so for geometric distribution, when you have probability of x is equals to r, okay, so that is pq r minus 1, and don't forget p plus q is equals to 1, okay, and for p x x less than, yeah, we have for less than and we have that for greater than. For x less than r, so that we have x less than r, then we also have probability of x greater than or equals to r. Okay, so this must be less than and this one should be greater than, so greater than r. Okay, so for probability of x less or equals to r, we have the formula to be 1 minus q raised to power of r, and greater than r is q raised to power of r. Okay, now since you are looking for the first success before fifth attempt, now before fifth attempt, that is probability of x less than r. Okay, Now we can rewrite this as probability of x less than or equals to r minus 1. Okay, now so here where r is what 5, so this will just be probability of x less than or equals to 4. So if I'm going to use the equal sign, but without equal sign, that would be less than 5. Okay, but we need to make use of equal sign for us to make use of this formula that we have here, so which is 1 minus q raised to the power of r, and r here is 4. Of course, now the q here is 0.3 because Sussex is 0.7, so this is 1 minus 0.3 raised to the power of 4, and this will actually give us 0.9919. So that is that. Or another method for this is to find, since we are looking for the first success before fifth attempt, now that will be the first success must be between 1 and 4. Okay, so this will just be the first one, the first attempt, that's p, then pq plus pq squared plus pq raised to the power of 3. So we can find each of these, and of course we are going to have same results with that. So I obtained this formula from the here from pq for pq raised to the power of r minus 1. So when r is 1, when r is 2, when r is 3, and when r is 4. Okay, so when you make use of this formula as well, you have same results. So that is that for the second question there. All right, so let's move to C part. So we is a member of the same soccer club is also practicing scoring goals. So the probability that we will score a goal on any attempt is 0.6. So let me write out the parameters. 0. Scoring now, so we can just write that to be probability of x to be 0.6, and the probability of x prime will be 0.4. all right, so and this is independently of all other attempts. So we is going to keep making attempts until he scores 3 goals. Okay, find the probability that he scores his third goal on his on the seventh attempt. So this is looking like binomial and geometric. Okay, just looking like binomial and geometric, but let's check the question again. Okay, he's going to keep on making attempts until he scores 3 goals. You see, that's for geometric distribution. Okay, for geometric distribution, you keep on performing the experiment until you have your success. Okay, but this one, you are not looking for first success, you are looking for 3 of that, because you have to score 3 goals. Okay, getting 3 goals now is the success here. We are going to classify that as our success. Okay, that's the meaning of that. Now find the probability that he scores his third goal on his on his seventh attempt. Okay, so what we are going to do for that to score his third goal on his seventh attempt, that means he must have scored 2 goals, okay, in between the first 6 attempts. So while scoring the third goal will be on the 7th attempt. So we need to know the probability of scoring 2 goals in the first 6 attempts now. And for us to do that now, that's now binomial. So that means we are looking for number of success in n trials now. So 2 goals in 6 attempts. So that is binomial. Okay. And for us to get that now, that will be n for that will be 6. Because of course we are left with, we've removed the 7th attempt. We are saying we are going to get the first 2 goals from the first 6 attempts. So n will be 6 now, and r will be 2, because we are looking for 2 goals. Okay, so that will be 6 combination 2, and the success here is 0.6 raised to the power of 2 times 0.4 raised to the power of 4. So this is the probability of scoring 2 goals, okay, in the first 6 attempts. Now scoring a goal in the 7th attempt, now that will now be 0.6, because we have it here that score a goal on any attempt is 0.6. okay, so you just multiply that. When you use the calculator, I think here this should I'm not with my calculator, but we can actually do that. So and we have the final answer to that. Okay, I've checked that. So the answer here is 0.0829. Okay, so that's for the questions. So this is the solution to the first two questions there. So if you are just joining us for the first time, kindly click on the subscription bell so that you'll be notified whenever I release another video. Thank you. So I will release another video on the remaining solution to the other questions that we have here. Okay, so stay tuned to get that.